Properties of real numbers. This will be a pretty quick one. And again, it's just kind of a lot of vocabulary and conceptual stuff and not a lot of real math. So first we define something called an identity. 0 is called the additive identity because if you add it to any number, you get that same number back. So in other words, 0 is the unique number by which addition by it does nothing. Okay, so that's why we call it the additive identity. Now for multiplication, just think about it. There's a number that if you multiply it by any number, you just get the same number back. And that number is 1. You probably knew that. Any number times 1 is just itself, right? So same concept. You get back what you started with. So 1 is called the multiplicative identity. Okay, the commutative property. So it's not as important to me whether or not you remember, oh, this is what this is called. Oh, I'm using the commutative property. It's more that I need to refer to this stuff in the future, and just think of these as just rules that you can just use now if it makes the math easier for you, rather than thinking, oh, do I have to explain that I'm using the commutative or the associative property here? No, I probably won't make you do that. But this is just stuff that you'll need going forward forever in algebra. Okay, so here's what the commutative property says. For any real numbers, so that just means any two numbers, a and b, that. So it says it doesn't matter what order you add things. You can do a plus b and b plus a, and you get the same thing, and you probably knew that, right? And you can do a times b and b times a, and right, 3 times 5 is the same thing as 5 times 3. You knew that. So the commutative property just says that holds no matter what. That holds no matter what those two numbers are, or if there's more numbers. If there's 5 numbers being added together, it doesn't matter what order you add them in or multiply. Okay, so that's commutative. Think of commute as being like back and forth, I guess. Okay, so that's basically what it says. Order doesn't matter. So I want to contrast that with this. Notice that if you have 7 times 3, that's not the same thing as 3 times 7, right? Unlike what we were just talking about. Same thing with division. 7 divided by 3 is not the same number as 3 divided by 7. In fact, they're reciprocals. So all that is to say, subtraction and division are not commutative, right? The order does matter with those. The associative property says we can associate different numbers with other numbers and it won't change the end result. So basically by associate means we can like put parentheses around certain numbers. And it's only when adding and multiplying. Okay, division and subtraction are a little bit more finicky, but that's what it says. We can group however we want. So when you hear the word associative, think associate like group together. A plus in parentheses B plus C is the same thing as A plus B in parentheses plus C. And A times parentheses B times C is the same thing as A times B times C. So these ones are probably a little more useful algebraically because it might be a little easier. So you might have to move some stuff around in like a product if you were multiplying like 3 or 4 things together, and it might make your life a little easier to do it that way, to group it a little differently. Okay, and this just says like that thing that you think that you can do, yeah, you can totally do that all the time. And now we'll talk about our friend 0. So 0 is something we have to just be really careful with. It seems like it's a simple number, but it behaves differently than any other number, and you know that. So in particular, if you multiply anything by 0, you get 0. It doesn't matter how big a is. 1,000,000 times 0 is still 0. Okay, so you know if you think about it, okay, 2 times a is a 2 times, and 1 times a is a 1 time, while 0 times a is a no times. So that's just 0. Okay, so it works out like that. Similarly, similarly, if you take 0 and you divide it by any number a, you also get 0. So think about like, if I have nothing and I divide that into 10 parts, what are all my 10 parts equal to? Well, still nothing, right? If we chop 0 up into as many little pieces as we want, all those pieces still have no quantity. So they're all still 0. Okay, and then here's the important part. Not to be confused with, if we just flip that little relationship around, we get something vastly, vastly different. All right, so this is the first thing in math that you just can't do. So the word undefined, it doesn't mean like I'm not telling you what it is yet. It means that it absolutely has no mathematical definition whatsoever. Putting a divided by 0 has as much mathematical meaning as if you just drew like a little piece of pizza or something on your paper. It's fine to write, but it doesn't. It has no value mathematically. I want to try to explain why a little bit because it's so important. Basically, think about it this way. If I have a pizza and I was to tell you, hey, chop that thing into 10 pieces, 5 pieces, 6 pieces, whatever, you can divide it into as many pieces as you want. But if I tell you to divide it into no pieces, right, you can divide it into one piece by doing nothing, but you can't divide something by nothing, right? You can't chop something into 0 pieces. Here's a little more of a mathematical way to look at it. Okay, so that's what I just said. You can't divide something that has stuff in it into 0 parts. I'm going to try and convince you of it now. If I say 15 divided by 5 is 3, I can say that, and I know that because 5 times 3 is 15. Those two things are synonymous. They're just two ways of saying essentially the same thing. Okay, now let's try it with 0. Let's try throwing 0 in there. So if instead of 15 I say 0 over 5 is 0, which is true, well, that is true because 5 times 0 is 0. So you see how this statement comes right out of this statement, right? These essentially are two sides of the same coin as well. So if you believe this, then you got to believe this, right? And that's the same thing as here. All the stuff goes in the same place. But if I try to flip that around, if I tried to say, okay, now 15 over 0 is something. Okay, so there you go. If I write 15 over 0 is something, whatever's in that blank. Well, that's implying that there's some number out there where the 0 times whatever's in the blank gives you 15, right? Like compare that to this. 5 times 3 is 15. 5 times 3 is 15. This says that 0 times something is 15. Well, now look at that statement and it's ridiculous because there's nothing like that. There's nothing we can multiply by 0 to get 15 or any other number for that matter, right? Ever. So 15 wasn't special there. It's just the number I was using as an example. Okay, so division by 0 just makes no mathematical sense. And it's really the one thing in mathematics, and no matter how high up you go, there's no way around it. Okay, you just can't get around the fact that you can never divide by 0. Okay, so there just are no numbers like that. Just doesn't compute. Try it on your calculator, you'll get an error. So from now on, we have to avoid that in mathematics forever.